This is the first time I've given this presentation. It'll probably be the last time, so bear with me if I make a mistake or stumble. But anyway, I'm going to show some Perl, eventually get to some Perl, via ink, paper, metal, and oil. And a little bit of elbow grease too. And just a little pre-launch check. If you're looking for in-depth Perl, you're in the wrong room. We'll eventually get to it, but it's ancillary to the presentation. So just some introductions. My name's John Whitney. I got a ASCII degree in 1980. I still program for a living. I have two technical assistants. We have Stephen, we have Brian, and we have an administrative assistant in the back, Joy. She may be helping us with the awards and so forth. So this project started two years ago, and I was wondering if it was possible to take the old technology and make it useful in a way in today's world of computers, so that even my kids could use it. So I just want to ask, who here prior to today knew what a teletype was, just by a show of hands? Okay, about half. And who has seen one working before today? Okay, we got two. And who's used the teletype in their work? Okay, we have nobody here who's done that. I have actually used them in my work, but it was many, many, many years ago. And is there anyone here who's a member of a company-sponsored club? That would be like a ski club or a tennis club. Anyone? A member of something like that? You'll see why that's important later. So my goal, and I'm going to move quickly because I got a lot of slides, and we're going to do a presentation where you guys can use the machine. So I'm going to go quickly. I wanted to get this, talking, basically to this, getting the news, the weather, send email, talk to Wikipedia. And we're really looking at a bridge of 50 years. These machines were launched in 1963. This is 2014, so over 50 years. So I'm going to show how I got everything working, some history along the way. For some it will be nostalgia, nobody in this room. For others it will be a window on past computing. We'll do a demonstration and we'll have a couple awards in the middle. So we have terminals, these machines here. We have converters to talk to a Linux box. We have software in the Linux box, and then we're connected to the cloud. So I decided to go with the electromechanical devices. These are the first front-end I/O devices for computers back in the early days. I went with off-the-shelf converters and some custom stuff I had to do. I'm using CentOS, Red Hat, Linux. And the software is, you know, Bash, Perl, CPAN modules, Modulicious, and then connected to the internet. So teletype data terminals. Why teletypes? It's a fascinating company if you know a little bit about the history. They were filled with engineers, and they took electromechanical technology to the limit to send and receive data. And a lot of their designs, their clutches, were pure mechanical marvels. They were the first I/O devices for micro mini computers. And they'll still be functioning 100 years from now. These things, it has one, maybe two transistors in the whole thing. The rest is all electromechanical magnets. And it was a very family-oriented, family-centric, employee-centric company. And I'll show you a lot of pictures as we go. This was, every year they had Family Day. And they would let kids of the families, parents, wives, spouses. This is a funny picture because these are actually IBM key punch machines. They have nothing to do with teletype, but I can see the kids are enjoying them. So I'll do more slides on teletype later. But I wanted to be able to print, type, punch, read tape. I needed two machines because I got two kids. And they had to be identical so the kids wouldn't fight over them. You know, who's got the better machine. And they had to be relatively lightweight because we had to move them up and down stairs. So I had to be under 70 pounds. So what was available? I had these machines. These are KSRs, keyboard send and receive. These are designed to run 24 hours a day, 7 days a week. They're very highly engineered, but they don't have a punch or reader. These are automatic send and receives of the same units you just saw, but they weigh over 225 pounds each. They're pretty hard to move around. So I had these two, and they had everything. They're a little lighter, paper, tape, punch. they're a little ratty, a little bit need to be restored. So I went through them and completely refurbished them, and I'll show you how I did that. You can get these on eBay. They come up, I would say, every 3 months you'll see one, and they go for, like I show, $500 to $3,000. This is a non-functioning unit, but in pretty good shape. It sold for $2,300. 10 years ago, they were going for $50 to $300. So basically, the process was to take everything apart, keep an eye on anything that looks out of place or in need of repair. For example, this machine had a belt that was ready to go. So I had to replace that belt. You can't quite see it, but that arrow shows a tooth on one of the gears is missing. And I discovered that when I pulled it apart. So where do you get parts? It pays to have a parts machine. And this one a friend of mine picked up in California for $50. It looks awful, but it turned out inside it was like almost in mint condition. And I got a lot of really good parts out of it. Or you got to know this man. He is been repairing teletypes for 40 years and has millions of parts and tremendous amount of knowledge. He's an expert that's in a field of where all the experts are dying. This is just a view of the side of the keyboard, and the keyboard alone has 100 oiling points, and it's actually designed that as you oil it, the oil drops down and then there's pads underneath to collect oil. But the key is you don't want any oil. I'm not very good at this. Let's see if I can get back to where I was. You don't want any oil here. These are actually the 7-bit ASCII connectors. So as you press a key down, it touches these metal bars and creates the electrical connection. I restored the feet. These are actually nickel-plated steel, and somebody had spray painted them. I just had to get that off, and they look great. I re-inked the ribbons. Then I started putting everything back together. If you're going to do something like this, make sure you got carts. It's really easy to spin the object around as you're working on it. And kids were curious what was going on. And this is that same belt and machine that we saw earlier that was all greased up and gunged up. Now it's got a new belt on it. This is inside what some of the mechanics looks like. These are actually the code bars where you have the 7-bit ASCII characters, and as they go up and down, they spin this head up here. They raise it and spin it to get the right character. This is just one example. There's 50 pages of how to oil these machines, and there's about 500 oiling points. This is just half of one page showing on this mechanism, O is oil, D is keep dry, and they have another one which is G, which is grease, and everything was O or G or D. So basically got everything running. One problem I didn't get fixed, but I went through the community of Teletype people and nobody figured out. It didn't affect its operation, so I moved on. It was finally working. I buttoned it up. Then I had to work on machine 2. And I won't go into so much detail, but I'll show a few things. This was actually the machine Brian's in front of. It's almost brand new. It had almost no use, and it was a real pleasure to go through. This is the keyboard with it all. You can see how it would have 100 oiling points. So you oil it and it all drips down. Most of the parts were washed in the kitchen sink. This you can see an upgrade where they created this plastic frame to kind of protect these contacts so oil wouldn't get on them. This is the keyboard. This literally looks brand new. This is very rare. Now for the first award, I want you guys to guess, guys and gals to guess what this is. And the award, the first award, like all the awards, are 25 IBM key punch cards from Los Alamos National Labs. This is what they use to do inventory. And one second. And they make great bookmarks. Okay, so you had a guess.
I want to say this is quality assurance.
Quality assurance. Okay, good guess. Who else has a guess what this might be? These are people who worked at Teletype Corporation.
Recipes.
What's that?
Recipes.
Recipes. That's a pretty good guess.
Words per
What's that?
Words per minute.
Words per minute. What's that? all the typists they had. Gosh, none of you guys are close. Who should we give the award to? I think the recipes. This is kind of original. So Brian, can you give him the award? But this was, let's see, did I do it? Yeah, here it is. It was an employee beauty contest. And the way it works, and this was in 1965, they did this every year. It was called the Teletype Queen Contest. And 6,000 employees, they nominated who they want. They would get like 150 nominations. Then there was a Teletype board, and I don't know how they narrowed it down to 10 finalists, but they did. And then the finalists would visit the factory floors. They would visit the cafeterias, and all the employees could meet them. And then the next month, the employees would vote for 5 of those 10 finalists. And then they would announce those top 5. And then they had a huge ball. They had a huge ball each year, and they crowned the winner. And this is an example of that ball. She became the winner this year. And there were many perks of winning. One of them was your picture was put on the parking pass of all the cars. So as people in Chicago drove around, they said, "Oh, there's a Teletype Queen. That person works at Teletype." So that was one of the things they did. This is a press photo of her that year. This was from the Chicago Daily News. And she then also became a representative of the company. And she would tour customers. Here she's touring a radio station. If any of you know Bozo the Clown, this is the ringleader of Bozo the Clown, the TV show in Chicago. Teletype used to hire this gentleman, Ned Locke, to do their Christmas parties each year. So anyway, that is a fun little tangent. This is the machine number 2. It's totally restored. Let's see how I'm doing on time. Okay. Next award. Who can guess what this is? It's a part in the Teletype. What do you think it does? Yeah.
Is it part of the feed?
Part of the feed, okay. You what?
You pointed to that earlier, didn't you? Wasn't it the top left, the Teletype?
No, I don't think I pointed to it. Sorry. Any guess what this part might do?
Pushes the oil down?
Pushes the oil down. How are we going to pick a winner? Brian, you pick a winner. One of these 3 guys, okay?
Push the oil.
How about this gentleman who guessed first? Or him? Dave. Let Dave be the winner this time. This is actually a security device. And there's a key in the keyboard called Here Is. And when you hit the Here Is, Brian, can you go into local mode and hit the Here Is key? Just, yeah, pass it around. Let them see it. So what that did is it spun this thing, and if you take off these little pins, you get ASCII characters. There's 7 pins, and there's one that says stop. Okay, Brian, that's enough. Go back to online. So what happens was, on a modem, you would send a signal to one of these machines, and it would be an ASCII character that says, "Send me the Here Is character." It would then print out a code saying, you know, I'm Chicago Office 73. So if you were in New York, you would know you're talking to the Chicago Office 73 computer. So it was a slight security device. Now I've programmed it to have his name and his name. So when he hits that key, he can sign anything he wants by just hitting that one key. And that little device is right here, and it spins, and there's 7 contacts for the ASCII characters. So when you hit that Here Is key, it chatters away and sends that signal out. So machine 2 is done. This is a brochure of that time. This was their first ASCII device. And ASCII was a big thing back then. There was a lot of character confusion. We take ASCII for granted today. It was started in 1960. Teletype before existed in the Bordeaux world, where they had pretty much only 62 characters. They had 32, which was 5-bit, and then they had a special character that shifted between the 2 sets. So you couldn't do upper lower case. These machines had 7-bit ASCII, but they still didn't do lower case. This is just to give you some idea of what it was before ASCII. All the different companies and their character codes. There's even a PDP-1 up there, IBM, NCR. And they used to promote it. This is a card that would help you read paper tape holes on the punch tapes. So if you follow a pattern, you could see, you know, like this is a bell, and then you would have to follow here. They made about 700,000 of these machines. When they made the 500,000, they plated it in gold, the whole machine, and they put it in their museum. And this is actually a picture. I don't know where the machine went, but be interesting to see one of those. So then I needed to get from these machines, which are now working, to my Linux server. So they, they operate at 20 milliamps current loop. And we got to get to RS-232. Up there we have a voltage, let's say it's 20 volts and it's just 20 milliamps just going on and off. Here we got 13 volts high and low. So I just bought a standard off-the-shelf converter. These are about 270 bucks, but they're passive and they're workhorse for 20 years. No reason to reinvent that wheel. But I built a custom device to sit between the data converter and the other computer. So I needed to convert baud rates. I wanted uppercase to convert to lowercase to go into the PC. I want to allow any character to be typed because a lot of characters are missing on these machines. I wanted the user to be able to have their own user-defined function keys, handle Control-C locally, 2 stop bits, 1 on the other side, convert some special characters. There is no vertical bar in the teletypes. I wanted to auto-force the carriage return at the end of the line, otherwise it just keeps printing. And I have a variable delay after when you get to the end of the line, because you have to give time for that printing head to get back to character 0 position. And I actually have it set up so it knows how far it is, and it varies the time to just what it needs. So I went to Elance. I needed someone to help me with the hardware. I found this guy 5 miles away, and he developed a simple circuit, which I then wired up. And this is the first hardware project I ever did. So this is a basic schematic. The software's coming in, you translate it, goes into the ring buffer that's going to go to the teletype. The other way, it's the same process, except there are some local commands. And I started out with the Arduino, because we're using the Atmel 328 chip. But Arduino was just getting in my way. They were taken off over the high precision clock and so forth. So I ended up going over to what Atmel used, for their own IDE, for their own chips. And it's 10 times better than the Arduino environment. It's very slick. You can write your code, you press a button, and 2 seconds later your chip is running with that new code. It's very fast. But I'd never used this program before, and it took me a week to figure out that's how you download. There's a little green button. And I was looking for a download command, and I'd never used one of these IDEs before. And I finally figured it out, but it was embarrassing how long that took. So my software uses the UART and the Atmel chip for the PC side I/O. I have a polling loop, which checks the teletype. It cycles about 50,000 times a second, and that's plenty frequent to do that. I use a 16-bit precision clock for timing. That goes up to about 37 minutes. So at 17 minutes, I turn on the flag, and I wait for some time when the main loop is not doing anything, and I reset that clock. And that's been working. I use the EEPROM to hold the shortcuts, and it's just like a memory drive with holes and mapping. You got to repack it when you run out of space. And this is where I finally got things working with my prototype. And the hardest thing was getting the flow control working. I never got hardware flow control working. I had to go with Control S, Control Q. And I don't know if it was a Linux setting or something wrong with my hardware. But it does work nice with the X on, X off. So then I redesigned that circuit that I had, and I used KCAD, which is an open source program out of France. It's really a great program. It's a little hard to use. Has a difficult learning curve. It was written by the guys in French or Switzerland, and it's unusual. Once you learn it, it's very fast. In fact, Stephen, for his science fair project, he used KCAD to lay out his own board.
Should I just pass this one?
Yeah, pass them both out.
Okay.
And these boards I developed with KCAD, and it's a free open source program that's really powerful. It has a 3D feature where you can see your board in 3D with the components, And I actually found an error with this. It turns out this point right here, there was a little via point gap. And it wouldn't have worked without fixing that. So that was nice. I found that. We sent the Gerber files to China to Seed Studio, their PCB service. And 20 days later, they arrived back. And they turned out to be very good boards. From the components installed to debugging the hardware, I thought it was going to take me hours and hours and hours because I really didn't know what I was doing. But it took me 2 hours, and I had one major fault, and I had the leads on the power regulator backwards. And once I figured that out, I just put it in upside down, and it worked. So that's actually upside down. But it's working. And it didn't even ruin it. You know, it was backwards. I put a new one in, nothing failed. No, we're not right now. So now I needed a Linux system. I got a converter. So I just went with this Dell I had. CentOS 6.0, nothing special, straight install. Then I needed some software. So for news, weather, and wiki, I wanted to scrape these sites. So I used Perl and Modulicious DOM traversal. Let me just show you that real fast. See if I can find the escape key. I know it's here somewhere. Have any of you guys used Modulicious? Modulicious? I can hardly say it. Sorry, this is taking so long. I should have had this already running. That's the doctor. Let's go to Wikipedia. So here is anyway, I can show you guys these programs. I basically use Modulicious to basically pull the page down, look for certain attributes. In Wikipedia, they have the main information. It starts with a P. It's the only P they use. So it was actually very easy to scrape their site. Yes?
So you're just using the Modulicious code to basically scrape the site?
Yeah, and do DOM traversal. That's all I used it for here. And I did that in all three packages, Drudge Report, News, and Wikipedia. And I did weather, the government weather site. See, am I going to hit the right key? No, there's the right key. Then I used the Perl source filter to do, I wanted to be able to program on these keys and actually enter in a Perl program. But it doesn't have things like open curly bracket or close curly bracket. So I had to somehow map these special characters. It doesn't have the vertical bar, it doesn't have the tilde or the backslash. And a lot of these are crucial to Perl and Bash and so forth. So I wrote a Perl source filter. And it turns out it's very easy to do this. So I just map all these into the character forms there. In fact, if I go back to here, in the code, if you put this in the code, it'll replace it with that. If you put a P, you know, or an OR. So actually I wrote a program that uses that, and you can see here now I have, this is open curly bracket, you know, this would be closed curly bracket, so on and so forth. And when you run this program, it actually runs, and it generates this output. And you say, well, what is this output for? This is what tells me which posts to break off on the here is wheel, so I can send out, you know, a message. So his name or his name. And here it's my name, John Whitney. So then the other things I did is I used the utilities like add BC, which is a calculator, calsay time calculator, calendar. Then for email, I had mail, postfix to send, fetch mail to receive, and then we downloaded a bunch of games like Monopoly, Doctor. So then using the system, I created a manual. I'll just show you this real fast. Is it going to go there? It's loading. It shouldn't take that long. Yeah, I'm probably not. So let me... Yeah, I'm going to stop that. Anyway, there's a long... you can see the manual here. It talks about how to use editor, how to use mail, how to turn on the teletype, how to use CalSay, how to use the calculator. In fact, let's pass one of the manuals around, Stephen, if you can, since we couldn't go online. So then I finally got everything working. And this is a picture March 8th. Where I finally got it talking to the web. This was the first output, and I could actually get the weather. And this was when the airline in Malaysia went down. This was the news coming off the Drudge Report. And then I taught my kids how to use it. And here they're howling with laughter, and you see printouts everywhere as they're running the doctor program. And okay, so that's that. We're going to do a demonstration soon. I'm going to let you come up here and use the machines. But I want to just share a little bit more about Teletype Corporation and what was unique and or how it was very different 50 years ago. They actually made all their own parts. And they made about 35,000 different parts that went into these machines and other models. And they brought in raw materials, did their own stamping, machining, they did their own plating, finishing. The amount of steps that goes into many of these parts was really quite amazing. They also had a program which was a suggestion program, and every month they gave out awards to people who submitted ideas, and they gave out awards thinking whoever's was the best one. This one gentleman, he got $550 in 1967, which is about $3,800 today. That's not a bad little suggestion award. They also celebrated engineering. They had every year they celebrated Engineers Week, and they had special programs. They brought in special speakers. They had seminars. They had a huge banquet. Here in '67, they had 500 engineers that went to this banquet, all working for Teletype. Another interesting aspect is they had so many organizations, you know, chess club, ski club, junior achievement, bowling, vacation tour, summer picnic, and the list went on, that they had a board of directors just to manage all their clubs. And here we got like 15 or almost 20 people here to manage all the club activities. They had an employee hobby show each year where all the employees would bring in things that they do after hours. We have the choral club performing there, dancing. This guy's with the radio club. This guy's a boat builder. She's doing egg painting, and they're doing grapho analysis. I'm not sure what that is. But they're all dressed up to do it. They had a chess club that they competed with the employees. Okay, for the next award, I want you guys to try to guess what this is. What is this group?
Winter Olympics?
Winter Olympics, okay, good question, good guess. Triathlon? Biathlon. A what? Tic-tac-toe. Well, I'm going to give the award to, what was it you said again? Yeah. Winter Olympics. That's pretty close. Brian, give him one of the awards. What's that?
Complaint department.
Complaint department. And actually, this is the Illinois Bell Rifle Team, and this is Don House. He helped me a lot on this project. He's really into teletypes. But what's kind of funny here is that his team would compete competitively with the Teletype's gun club. And Teletype had multiple gun clubs. They had the handgun club, they had the longbow rifle club, and they used to go and shoot with IBM or shoot with Bell or shoot with all these different companies in competitions. Then they also had a fashion show each year, and this one they had 300 people attend, and they would do this every year in Chicago. They also had an evening school, similar to like community colleges. And this is some of the employees who had done art that they had learned at the evening school. And these are some of the subjects they taught: sketching and painting, cartooning, music, guitar, dictation, and they also had electronics and digital logic. They had beginning Russian. I'm not sure why they did that. Knitting, and they had screw machine theory, which is it's not what you think it is. Then they had a choral club. This is all employees, and they practice every Wednesday in the auditorium of the company. And this group, they performed 2 hours in this example for a 500-bed hospital in Chicago. And their next performance was going to be at the Tool and Die Institute graduation ceremony. So imagine your companies, and think about, do your companies do any of these things today? They might have a basketball court or a volleyball court, but that's usually the extent of any company activities. Anyway, I wanted to share what they did. They also were very famous for their picnics, and they did this every year, a company picnic, and got all the families and the kids together. So that's the end of the presentation. We'll get to the demonstration shortly. First, I wanted to give you my contact information if you want to get a hold of me. My number is 77.04. And some of you might not know how to use that to get a hold of me, so I'll explain that. What you do, just remember that number, and you add it to pi. And if you add that to pi, you get this number, and that turns out is my phone number. That's my cell number. So you just got to remember 77.04, and you can get a hold of me. It was funny, I didn't realize this, but my young gentleman here, Stephen, he was reading a comic book, which is Donald Duck and Math Magic Land. And in there, they were talking about pi and the sequence of numbers. And we were surprised to discover that 6 of them were in my phone number. So he was the one who discovered that. So that's my cell number. That's my email if you want to get a hold of me. And you can also see a lot of these pictures on the web at this address, which we couldn't get to. But so I want to just give a couple people credits. I had people from all over the world who helped me on this. A lot of very good people in the Teletype community. Some of my neighbors who encouraged me along. A lot of good people there. So any questions? Yes?
So what happened to Teletype?
What's that?
What happened to the company?
That's a good question. And in fact, I don't have a clear answer. I've read a number of books and talked to people, and it's really a combination of things. Number one, they were really into the mechanical design, and they started to get into digital and electronics, but they were really, in my opinion, not at the forefront of that. In addition, they were a subsidiary of Western Union, and Western Union really didn't want them to succeed because they were doing their own things. Western, it might have been Western Electric. But so there were some conflicts there, and then the whole split up of the Bell system, they kind of like fell through the cracks. They weren't allowed to compete, and so it kind of all fell apart in the early 1980s in that time frame. And it was basically wound down and shut down. So here's some rules for the demonstration, and I'm going to let you guys come up and use these machines. First of all, be gentle. Don't type 2 keys at the same time. There's a lock in there so that you can't, but you can bend that lock. Ask before you push an unknown button if something's not clear. And don't type any malicious shell command to take over the system or create a kernel panic. Because you can do that. You're talking to you can send an email message by just typing mail, your address, and you can type away. There will be a subject line, and then you just do a single period and carriage return, and a mail will go out. I think it will go out here. Normally I can get fetch mail running, and I think I have it working here, but I haven't tested it. And that's it. I want to thank you guys for all listening. It's not getting to the weather signal, so you better debug this. So it's waiting for someone to ask or tell them their problems, you know. You have IN on that? I'm sure it's not pleasant to be sick. You guys go ahead and type stuff. It's, you know, there's like the calculator BC. BC is a very complicated calculator developed by Bell Labs. So you can do like 34 times, you can do any equation, 56. You know, pi is in there, so I could say pi times 5 equals, and it'll print out the answer. Q. So if I wanted to send mail, well, I can't get to the internet, so I can't do that. I can't remember how do you tell? So if you want a calendar, these are all these links.
It's really cool.